Alright, welcome back to the first stream of 2018 if you're catching us on the archives, or if you're lucky enough to tune in right when we get the bits flowing. I was about to start and then I noticed that Tuco was in this absolutely beautiful location, and so I had to go move the camera over and get it set up. It's a little hard to see him. Let me see if I can get some more light on the situation. I think he's just really backlit. But yeah, let's see if I can also get the overhead view going. Oh, I had this working just a second ago. I might have to restart this camera. This is supposed to be an overhead view. There we go. It's a little bit laggy, but yeah. So I don't know. I could talk about all the random stuff I've been doing over the past week or two, but I feel like it's been pretty random, which is part of why I haven't been streaming. But yeah, there's, as usual, a bunch of ongoing projects and a lot of things we could be doing. I haven't really been doing much on the Tuco Flyer project since releasing the last video, but if you missed that video, definitely check it out, because it's a really condensed summary of everything that's gone into getting the flyer to the point where it's at right now, where it can track the cat and get that video back to the streaming machine. Here's back to a close-up view of the cat. Very backlit. So yeah, since the last video release, which was kind of just before Christmas here, I've been taking the last couple weeks as a bit of a reset, which didn't really mean taking a vacation or anything, but mostly meant like, you know, taking some time to think about upcoming projects and also rearranging the shop, so some different furniture layout and trying to throw out stuff that I don't need and reorganize stuff that I want to keep and that kind of stuff. And one place that led was a confluence of things where I had just assembled this Boldport kit, the ananas, the pineapple, and I thought that was a really cool kit, and I wanted to turn that video footage into kind of a music video at some point. And so part of what I wanted to do there was to both collect some footage for that upcoming sort of Boldport music video, and also just to convert some of the stuff in my shop that otherwise would just be trash into kind of artistic output that I can use for that video. So in this case, I already had a bunch of 3D prints that I wasn't really sure what to do. They were like failed prints and things like that. I was just noticing a couple of chats from the YouTube folks. Mateus says, is Super Chat usually on? Never paid attention to it. Yeah, I turned that on a while ago, and we used it a little bit, but yeah, it hasn't really been a thing that I've been like hyping or anything. And then David says, Happy New Year. Happy New Year, David. Yeah, it's been an interesting 2018 so far, I have to say. I certainly got caught up in the last couple days reading about all the details of the speculative execution vulnerabilities that people have been hyped up about. You may have heard them called Spectre and Meltdown, and that's been interesting. It's been interesting in that way where there's this part of me that's like always basically been like it's really hard to think about the current extremely thick stack of technology as ever being kind of anywhere remotely secure. And especially, you know, in my time working on operating systems and virtual machines, like it was really hard to see how security could ever come about as a result of the sorts of designs that had to be put into being able to run software and operating systems and CPUs at the speeds that we're used to. So I don't know, it's like in some ways kind of like, well, of course this is going to happen at some point, but of course it's also just like a really impressive set of demonstrations for just how far you can go using only side channels based on speculative execution. So it's pretty cool. Yeah, if anyone here isn't familiar, just the really quick overview of these CPU bugs. They're not bugs in specific CPUs, really. They're basically security oversights in the way that CPUs are designed these days. Like it's very low level, and there are some specific bugs that make it especially bad on particular processors. Like the Meltdown variant is specifically about privilege escalation. So, for example, you can trick the CPU into fetching some data before the privilege check would have been resolved. So the CPU doesn't have the data necessary to. Oh, Tuco's just joining me at my desk now. So the CPU doesn't actually know if the data is. Actually, I forget whether it's because the the page table data is deferred, so you're widening the speculative execution window that way, or whether it's just that those privilege checks never happen for speculative loads. But basically, you can get the CPU to do just a load of memory, a speculative execution of some code that includes loads and calculations, and you can get it to do that regardless of the actual privilege boundaries, which means that you can kind of, as a normal unprivileged user, you can trick the kernel code into just for a little while proceeding down a path that you've provided, and the CPU would revert those, would revert any of that execution before you get to the point of actually storing stuff to memory, and any side effects within the CPU get reverted. But a side effect that doesn't get reverted is the cache side effect of loading memory, which is allowed during speculative execution. And by probing for those cache loads using cache side channel techniques, you can extract just a little bit of information from that speculative execution, which, I think from an architecture point of view. Tuco, what are you getting at? You're just sniffing at my wires. Don't be chewing on stuff, honey. It's from an architecture point of view, I think people are used to defending against privilege escalation, where low privilege code ends up actually changing the execution path or writing memory into higher privilege code. But this is kind of eye-opening for a lot of people because it shows just how far you can go using only the ability to cause memory reads and then affect the cache. Hey, Tuke. He's getting into some stuff he shouldn't. Come on, boy. Mako MK says the CPU should have the information necessary to do the checks. Are you sure about that? Because right now, the CPU architecture doesn't include any guarantees about microarchitectural data secrecy and side channels. So, my understanding of the problem is that there is no 100% fix that involves only software or only hardware, because a lot of what's gone wrong is about the miscommunication between the hardware and the software side of this, as far as whose responsibility security is. So, and yeah, Meltdown was these Intel specific. Sorry if my audio is a little hot. I don't know why that's. Let me try to turn the gain down slightly. Or maybe that's actually fine. I don't know. Let me know. Yeah. Okay, there's some more information in chat. Yeah, I haven't actually read the original Meltdown or Spectre papers yet. I was reading the Project Zero blog, and Markan put together a nice summary on GitHub with a bunch of links to specifics of the individual bugs, but yeah. Yeah, so anyway, I don't want to make this stream super deep on Meltdown or Spectre, because I'm sure some of you have read a lot more about it than I have at this point, but it's certainly interesting, and it's one of those things that's kind of unclear what the specific impact is going to be, like who's going to be able to leverage these vulnerabilities, but it definitely has the potential to be pretty severe and just generally change the way people think about designing hardware for security. Because I think the thing that, at least to me, is like seems like the biggest kind of like really eye-opening demo here is that using what seems like an extremely weak microarchitectural capability, you can escalate that into something that is demonstrably a thing that users care about, like reading passwords out of another process. And so that's, I think, the missing link that has kept a lot of people from caring that much about security. Because, you know, I just feel like, you know, in my like brief history of actually looking for problems like this and trying to get them fixed, I just kept running into people just not caring. And like you'd run into a problem where like, oh, it's possible for this process to do this thing that it probably shouldn't. And people are like, well, what does it mean? And I'm like, well, it's hard to say. It could be really bad. And then people would start being like, well, it's not any worse than these other dozen things that are also really bad. And it just like devolves into nobody caring about security. And so it's nice to see it getting pushed in kind of the other direction, where people are demonstrably being shown that even these very weak capabilities can be used to get data that's actually meaningful. So that feels like the kind of inflection point in security research that might be coming about as a result of this research, which I'm excited about. Tuco really wants to play Bolt right now. All right. Ooh, I just barely saw where that went. I don't think Tuco saw it. Anyway, so TLDR, Spectre and Meltdown are interesting. Definitely read about them if you're interested at all in the security implications of CPU architecture. I also, you might see that I put this little bit on the Ananas kit if you saw that stream. So the last stream was just before Christmas. I was building this thing, which it was a nice opportunity to, you know, even though there's a lot of other kind of random work that I need to be doing that is kind of hard to stream, it's nice to just do a little bite-sized kit and put together one of these bold port kits. So this was the most recent bold port kit. It's the Ananas, or the pineapple, and it's this neat three-dimensional circuit board thingy-do. Are we servo AF today? I think we are. So it's these two circuit boards soldered together with a bunch of resistors, and it's actually a ring oscillator, or several ring oscillators. And so it gives you this nice slow fading, which is actually a little bit dim, so in this bright light it doesn't show up too well, but I was doing a lot of photography of this in dimmer light. And then, I don't know why, but you know, it's like partly because I'd been wanting to do some photography with this stuff anyway, and like wanting to get it like physically done with and out of the shop, and like wanting to maybe combine projects. I decided to make the Boldport Ananas music video also kind of like fluorescent and gooey and alien otherworldly and stuff. So to go with that, I ended up making my own little pineapple frond thing out of these layers of fluorescent. Well, so actually these are all just like lighting gels, because I had some lighting gels handy, and this still got some goo on this one. But the green one is just green, because that's the color I wanted it to be. But these other two layers are both fluorescent yellow. So it means that when you view it from this side, it's like fluorescent yellow. When you view it from this side, you're seeing the fluorescent light, but then filtered through the green. So it still glows, even though the green plastic isn't actually fluorescent, and that's just because I didn't have fluorescent green handy. But it also gives it this kind of neat edge lit effect, where you're seeing the yellow on the edges also as this kind of fans out a little. Oh, Took, don't do that. Hey. Go away. Not that. Tuco gets into plastic bags he shouldn't, and that was a big plastic bag I have from cleaning up the trash associated with doing a bunch of messy experiments. Mako MK says the fronds look like a registration error or a video compression glitch. Well, I mean, it's sort of a registration error because like they're all cut separately, but Tuco, stop that. Tuco. he's gonna rip holes in that bag and then it's not gonna work too well. Yeah, no, I mean, what you're calling a registration error, I think, is the natural result of being a human cutting things with scissors. So, like, if I wanted it to be perfect, I would have, like, adhered all the layers together and then CNC milled it, but I kind of wanted this effect, so I just cut them with scissors while taping them together. So, yeah. Anyway. The other thing that might be a little bit noteworthy about this is the way I attach them. I used a bunch of this really viscous UV cure resin, so it kind of went with the gooey aesthetic I was going for in the rest of the video, and it also dries pretty optically clear, so it kind of hides a little bit of the gap there, and the lighting films, actually, I tried to notch them to help the glue adhere a little better, and then they were brittle enough that they started splitting around those notches, so the resin also helped to fix that area that was starting to crack apart after I was cutting on it. So I like this resin stuff. It's like, the labeling is medium viscosity. It's pretty thick. I don't know what their thickest resin is like, but it comes out kind of syrupy, and then surface tension kind of flows it nicely, and then you hit it with a UV LED for 30 seconds or so, and it's pretty solid. Took, quit that, honey. Ah, geez, I'm gonna have to take this bag out to the outside trash so Tuco doesn't eat it. Oh, James is asking about the tray of coin cells. Oh, yeah. I guess I had this handy because this runs on coin cells. Actually, I wonder, because it's been running off this battery for a couple days, I wonder how much brighter it would be with a fresher battery. Duke, quit that, honey. Focus. All right. Yeah, that's a bit brighter. Let's turn this one off at least. Oh yeah, this could be good footage. Let's do a little bit of this. That's a really thick bag, because I had a bunch of stuff in it that's kind of sharp, but he's still gonna... Tuco, quit it, dude. Dude. Let's see if I can at least get Tuco on camera if he's going to be a jerk. Which effect was not impressive on camera? You mean the frond or the LEDs or what? I mean, there's still a lot of light in the room right now. I don't really understand your criticism. Like, I don't personally expect this thing to be super bright. I'm actually really happy with the level it's at right now, but I guess if you want it to be bright, you could run it at much higher voltage or change the resistors. Oh, the gimbal sounds unhappy. Where's Tuco? Oh, he's over here by me. Good job staying in the camera's blind spot, Tuke. Oh, I don't mind the criticism. I'm just saying I disagree with it. It's pretty good in my opinion, but I can see how some people would want it to be brighter. Chico's just getting into all sorts of stuff over here now. All right, anyway, I'll try not to do too much rambling here. The point of this stream was I was going to try to actually do another of these, just because, as I was saying earlier, the ongoing projects are mostly in a state where I don't really have a lot of really good material to stream right now. Like, I just need to do some additional assembly on the winches. I need to put pulleys on the ceiling, which is mostly going to be begging someone to help me with the ladder and trying to get over my fear of heights, and just that'll suck, but whatever. And then I've got video editing and stuff to do for this next Boldport video I want to do. There's a lot more I could stream with some of the other sort of reverse engineering side projects, like the C90, that big Tandberg video codec thing, and that RS4M muscle stimulator thing that is a little bit locked out right now. So there's all that. I might show you just a little bit of the footage that I got from the mess behind me that I'm starting to clean up. So part of the point of this was a way of kind of upcycling 3D prints that had failed or were otherwise unused or unnecessary. So, like, a lot of people are like, PLA is recyclable, you can recycle it, but like, recycling centers don't actually take it. And I could recycle it myself, but it would take like thousands of dollars of equipment to do that, and I don't really want to commit the space or the money to that right now. So, so far, my best use for the failed 3D prints has been gluing them together in sort of interesting ways and photographing them and using them as backdrops for things. So that's what I got. And yeah, so it's just kind of a combination of a few different like weird arty things that I wanted to try to turn into interesting video B-roll. There's the failed 3D prints that I was sort of upcycling into arty detritus by gluing them together in interesting ways. And then I also just I like fluorescent stuff and like liquids and like flowing and like interesting patterns like that. And so I had done some stuff before with like fluorescein and turntables and macro lenses and stuff like that, which is how the little like scanlime slurping animation in the last video came about. So some of this is just like more of that, getting the disco ball motor and the sheets of glass back out and trying to do more of that. So let me see if I can show you some of the bits I got. There's still so much of this footage to go through, and I'm just now like rsyncing it onto the right machine and getting it into Premiere. Let's see what I got. So some of this is going to be like time-lapsed. There's just like goo flowing down. That's like one of the later, more weird, complicated shots. This stuff on the left flows very slowly. So you can imagine just like that with a bunch of time warping. Could even do like composited time warps of different parts of the frame at different speeds if I wanted to. Like a lot of this I'm probably going to like find the interesting pieces in Premiere and then just like bring it all into After Effects and just like mess with the levels and the color and the time to do whatever I want with the footage. Like think of this more as like textural raw material than just like stuff that's going directly into a final video. So you can get a sense of the sort of flow that you get over time there. And also like this is a music video, so imagine fluids flowing, matching up with the beat, things like that. Might be neat. So there's sort of a progression where the earlier footage was like mixing materials and like more like individual materials coming together. Then the later stuff was just like that kind of gets crazier and all the mixes start flowing and I just like started to get interesting shots using the complexity that came out of that. And then in the middle here somewhere, there's actually some shots with the ananas on a turntable on top of some of the goo. I didn't slime the ananas because I didn't want to like have to clean it. The most I did was like have it stick to a turntable full of goo, which was also kind of cool. I really like, oh, how did I open that? Stop that. I really like the texture of the goo flowing over the 3D printer infill here. Oh yeah, I posted a bit of this footage on Twitter. Good question. M. Druitt says, what happened to that keyboard you were working on fixing? Last I saw you tried it in VM and no issues were found. Yeah, that's the last state of it. I should probably bug Bill about that again to see if I can get more information about the problems folks were having, because yeah, last I know about it too, it's like I hear about some problems that folks are having with this accessible keyboard under newer versions of Windows, and so we try it out and can't reproduce any problems. It just seems to work. So that's all I know about that too. Yeah, this stuff is fun. This is just like PVA borax slime, which you can find all over the internet. But I made a couple of different batches of different consistencies with different pigments. I think this one is the thinner stuff made with just pure fluorescein as the pigment. But then the other batch, like the stuff on the right, was made using opaque glue, because that's what I had on hand. But then instead of fluorescein, I used this stuff from extracted from a highlighter marker, which is similar to fluorescein, but really actually pretty different. It glows a different color usually, and it seems like it glows even without water, whereas fluorescein is activated by water. Or, you know, I'm not a chemist, but it seems like with fluorescein, you need it to be in some kind of liquid suspension. So maybe other liquids than water work, but as far as I know, dry fluorescein doesn't actually glow under UV. This shot bugs me because I had the UV light on pretty dim, and you can actually see the pulse width modulation bands in the video here. So I'm gonna have to time warp this such that those average away, or clean them up with some separate post-processing step. That's annoying. Yeah, lots of dead prints here. Let me find some of the earlier bits here where I showed just more of that stuff. Oh yeah, this other material here, this white stuff, is RTV silicone caulk mixed with the highlighter extract, and then squeezed between thin sheets of plastic as it cures. So some of this is just like handheld camera. Actually, is this handheld or was this on the... Some of this was handheld, some of it was fixed, some of it was on the magic arm, but also handheld, so I was getting a little bit of stabilization. That might have been this shot. And some of it I was trying to just like rotate the entire camera stand to get a bit of a turntable effect, but I don't know how many of those are going to be stable enough to use. Oh, that might be nice. Yeah, these are all failed prints from printing the winch shells. Yeah, I need to really go through this footage and sort it. Like, I've just pulled this off, but oh yeah, here's some good, like, wearing rubber gloves and stretching silicone. That sounds fun. Did I just, like, yeah, and then here I just threw a bunch of 3D prints at the silicone. See, yeah, some of this will be useful. Those long skinny ones are this lamp that I designed and made enough of them to go above my whiteboard, but then I didn't end up building it and decided that I just didn't like the design, and then found those a while later. Yeah. And then this is another one I posted on Twitter. This was from the same setup that I had the Boldport kit on. Where's that actual footage? I think that was from this day. Yeah. Oh my god, yes, this one, this clip. Wait, where does this one start? I don't know if this is the right one, but one of these I just like could not stop laughing while I was filming it. Oh, it looks like I'm behind on chat again, sorry. Oh, someone said those might look incredible running backwards. Yeah, I'm definitely going to mess with the time warping. After Effects, which is kind of a new tool for me, but I've been really enjoying it. It kind of makes that a little easier. Joseph says, melt unused prints in a solvent, reverse the video. Oh, interesting. And then use that to do a Kickstarter scan, yeah. Re-extrude the filament with a machine. Yeah, I mean, I'm aware that filament extrusion is a thing I could do. It's just that it really is not economically viable right now. The tools are really expensive, and it doesn't really work that well unless you're doing it at a large scale. At least that's been what I've seen from trying to research it here. So, like, you need a grinder and an extruder, and like the extruder is going to be like a few $100 maybe for a really low-end extruder, and that doesn't include any like active diameter control or anything like that. You'd need a separate spooling machine if you want that. That also doesn't include the grinder, and the grinder actually, like, that actually is kind of a significant thing in terms of both cost and size and power. Like, it just, the kind of machine that you need to pulverize these prints into little plastic chips is just not necessarily the kind of machine I have room or electricity or budget for. Yeah, so anyway, some of this footage is going to be useful. For some value of useful. Will be useful for making a weird video out of, at least. I was worried because I thought I corrupted an SD card worth of footage, because there were a lot of video files in here that VLC has trouble playing. But in a crazy turn of events, VLC is having trouble with some of these that Adobe Premiere actually has an alright time with. Max on YouTube chat says the newest XKCD explains Meltdown pretty well. Yeah, I mean, at a pretty high level, yeah, that explains kind of the speculative execution side channels. Yeah, I generally feel like like 3D print recycling is one of those things that would be pretty useful, but is still like really impractical right now. Just like there needs to be a less energy intensive way of breaking up the prints, I think. Not sure what that should be. Maybe there is something where it could be, oh yeah, that's a good shot. Yeah, I'm into that. I think this is going to be a pretty weird video, but I'm having fun with it. Anyway, so that'll be a thing that I do probably mostly off stream, because I still don't really know how to edit video efficiently on stream, but... Oh yeah, I was trying to cut this stuff too. It's actually really difficult to cut. Anyway, so getting back to it, my plan for today's video is to open a random bold port kit and put it together, and so continue the cycle, get some more footage for making another weird bold port video in the future. So I think let's get on that. Got a somewhat clean desk here. All right, so there's a bit of a backlog here. Yeah, the kits have been coming in a little faster than I've been making videos about them, but a lot of these I don't think are labeled either, so that's why I was thinking this might end up being a bit of a random selection. So you might just pick one out and put it together. They do have dates on them, which we could probably use to figure out which is which. So here's November, here's August. But I think it would be more fun if it was a little bit more arbitrary than that. I've also got different shapes. September. This one's cardboard. Alright, this will be pretty arbitrary. Well, let's just pick this one. This happens to be from May, so some of you can probably figure out what this is going to be already. Let's make sure we've got some good video going. Rainbows 871 says they've been designing their own extruder and winder for about 150 pounds. That seems pretty nice. I'm still curious, like, how you're doing the grinding though. Is that like a separate machine? I assume that you're gonna have to design or build. Chris on YouTube chat says that the XKCD barely tries to explain it. It's not perfect either, but they like Joe Fitz's library analogy. Let's see if we can dig that up really quick. I'm not finding it in just 30 seconds of looking, so maybe I'll look for it later. It looks like here's a thread, but yeah, this is a little heavier than I'm into right now. Oh yeah, Cesar is telling me to watch out for address info, which yeah, I'm aware. I've got this tape on these packages. Oh. Oh, neat. This is the second Cordwood puzzle, which is a puzzle. So we might, well, let's go to the URL, but we might end up doing a kit without instructions this time. Stop wiggling. Okay. Alright, that's all that we got in there. Let's actually maybe go to the URL that's on there too. Two boards. Are they the same? They look the same. Yeah, they look the same. Let's get the instructions. Oh, I said they forgot about the grinder. It might involve hitting it a lot with a hammer. Yeah, that seems tricky. Because, like, you need, like, a chisel or something to get the pieces small enough, probably. Cool. Let's get a... I feel like I should be recording this too, to go with the DSLR video. It's nice to have screen caps of the instructions. So I think that actually exists on this machine. Is this the right program? There's so many different ways to capture video. Oh no, this is the microscope grabber, which I do want to have handy, but this isn't actually the right one. Be right back. I think the video grabber I want is on the other computer. Alright, got that recording. Great. Cordwood Puzzle 2. The second in a series of Cordwood puzzles. Our first Cordwood puzzle was very much loved, so we created a second in this... Sorry, I'm tripping over my own words. Our first Cordwood puzzle was very much loved, so we created a second in the series. In the 1950s and 60s, inventive engineers saved space by using the Cordwood assembly where components were sandwiched in between two circuit boards. This construction became less useful with reduced component sizes, PCB manufacturing advances, more compact integration, and surface mount technology, but it's still a lovely piece of history. Combining both old and new, the Cordwood puzzle is a tribute to this construction and to the engineers who came up with it. The puzzle is to correctly assemble the circuit with the components at hand. Once completed, all LEDs light up when power is applied. When connected to a controller board, each LED can be individually controlled. Unfortunately, all the comprehensive assembly guides were mysteriously missing from the kits. And then we have a parts list. We have 10K resistors, 220 ohm resistors, 1 mic capacitors, N-channel MOSFETs. We have a 10-pin header, yellow and green LEDs, M3 standoffs and screws, PCBs, and hookup wire. Great. Cool. And my impulse to just assemble this without the instructions is actually the recommended strategy this time. So let's get to it. And actually, as it says, this is the second one, and let me go grab the first one because I put that one together on an earlier video. Oh, it looks like we have reports of problems with YouTube. Still seems green, but who knows? Oh wow, Funky Squid on Twitch says that they're watching on the Echo Spot's circular screen, and it's surprisingly okay. That's pretty amazing. I don't even know what the Echo Spot is, but I'm assuming it's something Amazon does. I've been not really tuned into consumer products as much these days. So, this is the original Cordwood puzzle, and it's got 6 LEDs, which you can control all from these 6 pins here, with power on these pins. It's a nice little digital logic indicator that also kind of has a bit of a traffic light feel to it. And these beautiful resistors in the middle. Camera found the cat briefly. Now the gimbal's unhappy. Oh, come on, gimbal. Oh yeah, we need to have some gimbal-related work on the stream too. Alright. Just for reference, it might be kind of cool to take a look at the previous Boldport Cordwood video that we did here. Yeah, so this was actually Scanlime 17, the original Cordwood puzzle. This was a pretty slow and methodical video by compared to the kind of like quick music video style that I ended up doing later. With a shorter lead frame inside and the longer. So, yeah, it might be interesting to think how to maybe make this video a little bit different than that video. Because that stuff was nice. I like the kind of like shorter music video style, especially for stuff like this, but there might be places where I could have longer breakouts if there's something longer and interesting that happens. Got some good microscope photography in there, though. All right. Back to reality. So we've got these two boards. Warm up the soldering iron. Got all of this stuff. So I think I want to assemble all of the non-cordwood components first, and then figure out where all the cordwood stuff goes. I assume that everything except for the resistors and wire and this capacitor would be non-cordwood style. These are the 10K resistors, brown, black, orange. These are 220K, red, red, brown. Oh, Tomas on YouTube chat asks what we're building today. This is actually a Boldport kit. This is kind of an older one, but it's the Cordwood Puzzle 2. And if you're not familiar with Boldport, they're like a monthly electronics kit subscription service. And the kits are all really interesting and different and artistic. And this is kind of a sequel to a kit that they did earlier, this original Cordwood puzzle. And so the idea here is that it comes without instructions, and you figure out what goes where, and the resistors and some of the other components end up mounting between the boards like this, and kind of an homage to a 1950s and 1960s era construction style. So this is another one of those. And this is the previous one we did, the ananas, or the pineapple, which was kind of a neat three-dimensional circuit here. And I assume that just like with the previous one, we want the pattern side of the board to be on the inside, and then all of the non-cordwood components go on the other side. So I think we could start out by populating these two boards. It'd be nice to look at the circuit a little bit and try to figure out what's going on, though, before we start soldering anything, just to make sure that this is the right path to be going down. So maybe the microscope's the right tool for that job. Oh, also Tuco's on the couch. Let me see if I can follow him with the cat robot. That gimbal is unhappy with me. That's better. He's behind a pile of cat robots. Yeah, basically. Man, circular screens are so strange. I wouldn't have really anticipated that that was a thing that people would have wanted so much. Well, Took's having a good time over there. Yeah, great. Oh, let's turn on the microscope recorder now that we're here. Gotta have all the different kinds of footage. And this is why everything here is made out of hard disks and HDMI cables. All right, microscope. Oh, that's right. I've got to make sure to record the microscope not with the software that comes with the Elgato capturing thing, but with OBS, because the Elgato software, what just happened? Oh, I reset the capture card, which caused the HDMI chain to renegotiate video modes, I think. Yeah, so the software that comes with this grabber wants to de-interlace the video as a separate post-processing step, which is really, really slow. So yeah, I've been using OBS instead to capture it and de-interlace at the same time, which seems to work much better. And then, of course, Dr. Toon found a different way to, well, he found like a serial port and some firmware changes you can make on this particular microscope to get it out of the interlaced mode, but I haven't gotten around to doing that on mine yet. Anyway, that's recording. Optical mouse hacking. How did we get on that topic? That seems pretty cool. I have seen some optical mouse sensors you could connect to over SPI and it would give you the image out, but it isn't a guaranteed thing. Not all sensors let you do that. Increase working distance. All right, so we have 2 copies of this circuit board. Okay, Tomas says that the YouTube stream was acting up, but it seems all right now. We have 69 people watching. It's pretty nice. Got a nice shiny Boldport logo. And some good copper squiggles and stars and things. So we might be seeing another kind of signature SAR drummer move here where the different kinds of signals are indicated with different symbols here. So these pins are marked with a star, and then these pins don't have a star. And then these are for the LEDs. Where's that going? I think that wire isn't actually a wire. That's funny. Oh, could you see that thing I was pointing at? Maybe I should be using tweezers or a knife or something. Yeah. This trace, I think, is a nice red herring. It goes from this silkscreen outline to this silkscreen, but I don't think it actually connects to anything. Unless it connects to there. But so far it looks like these LEDs are connected between, so like maybe this goes through a resistor to ground, and maybe this is kind of following the same pattern you might expect for like LEDs and this kind of board, where the resistor goes between this and maybe one of the star pads on the other board is ground. Although, no, that's probably, yeah, maybe that is ground. Actually, it would help to know which one of these is the gate on the transistor. Because I don't have these pinouts memorized, but we could easily look that up. What is this transistor? The 2N7000? Let's look that up really quick. All right, gate's in the middle. So that would be pin 1, source, gate, drain. So yeah, it should be source, gate, then drain from the top to the bottom here. So I would expect source in this case to be ground, and it looks right if that's like a positive power input and that's negative. And it looks like this might be a combination of a power entry connector and a way to pass the power to the other circuit board. So this is going to be ground. Where the other transistors get their ground. Are these two connected? Or do they need to be connected somehow? Ah, those are connected. Cool. So these should all already be connected, all the sources for all the MOSFETs. Cool. And then the drain goes to the LED, which means this pad would be the LED's resistor. That's all making sense. So then, how do we mirror the boards? The boards are going to be mirrored across this vertical axis. That's where they're symmetric. So, let's see about the gates on these transistors. I assume the gates are going to have like a pull-up resistor. So that would connect to here. I guess in this case the stars are indicating different kinds of connections. So the star would connect to the star, but that would be a different value resistor. So this is going to be a 10K pull-up resistor. And this doesn't have the star. In this case, this is going to be the 220 ohm series resistor, because it'll go between the cathode of this LED and this should be ground. Oh. No, maybe it isn't ground. Oh yeah, sorry, this is going to be positive power rail. So this is the anode of the LED, and then the cathode is going to the drain on the transistor. That's right. So this should be positive voltage, and it is. Great. So this looks pretty straightforward. We just put the transistors where they go, we put the LEDs where they go. The side that connects to the resistor here is positive on the LEDs, so the square is positive. And then the stars tell us where the 10K resistors go. So for example, this one is plus, this one is a gate, and then the ones without stars tell us where the 220 ohm resistors go. So let's do that. I think that's right. And let's use one of these coin cells we have handy to see which polarity is which for these LEDs. We also get to just put the LEDs wherever we want. I think the colors are up to us. So the LED lights, if I give the long lead the plus, which seems right. So the long lead goes in the square. So I could, for example, put that in here. These are so long that I have to put my vise on top of something else. So, I mean, it seems to make sense just to put these in kind of an arbitrary, like, checkerboard pattern. Long lead in the square. Oh, good question from Jason. Are there different squiggles for yellow or green? Huh. I don't know. It doesn't seem like that's obviously the case, but maybe I'm missing something. Alright, so there's the LED tops. I think I'm going to want to solder this with the LED tops just like on the table to keep them all flat. Because that seems to line them up against the circuit board pretty well if I just like put the LED tops against the desk. Kind of. You have to be kind of careful about it. Oh, and Jason says to start with the transistors because they're shorter. Yeah, that's a pretty good idea, actually. Because otherwise, the transistors will be hard to line up flat. All right, thank you. Let's do it your way. All right. I think the next tallest might be the connector, although we haven't really thought about where the connectors go yet. Just trying to gauge how much I can rely on that for flatness. It seems to be good enough. Let's clean this gummy iron. Yeah, I could also be doing the thing where I tack them on from the top side, and then trim them, and then add nice solder balls on the bottom side. I don't know if I'm going to do that this time. It'd be nice if the microscope didn't keep changing exposure. It is really satisfying doing stuff under the microscope. I need more excuses to do this on this stream. Okay, we can trim these. Right? Seems pretty good on top. Maybe I'll just do that on the other circuit board next. Oh, nice. Kate Johnson in Twitch chat says that they remember assembling this kit. Yeah, I'm working on my Boldport backlog, so any of you who are already members likely have assembled this one in the past, unless you also have a backlog. But I let them pile up because I imagine the most complicated video I can possibly make for each one, and some of that's good, but some of it I need to cut out and just do simpler videos. got the smoke absorber set up right here, it just isn't even on. Let's try that out. Oh, that's probably super loud. Maybe I won't use that much right now. Alright, Jason says the smoke sucker isn't awfully loud, but it would be annoying if I wasn't soldering. Alright, yeah, that seems alright. Where's the microscope? There's the microscope. That thing where when you're paying attention to only the view of the microscope and the field of view is just really easy to lose. It's like more of a thing when you're looking into an optical microscope, but even with this one, when I'm staring at the monitor attached to this microscope, the actual work area is like not especially visible. Like it's kind of in my peripheral vision, but not really in a usable part of it. And then with optical microscopes, it's usually completely invisible. Oh, did anyone else see the latest build from Noe and Pedro at Adafruit? They made this this open source 3D printable time-lapse camera rig, like a time-lapse camera slider. It seems super cool. I'm gonna try doing something like that here. I'll be able to do some of that with the Tuco Flyer camera, but it would also just be nice to have more ways of moving around my camera. I was especially wishing to have something like that when I was working on like that kind of 3D print slime ananas photography the last couple days, because it would be nice to have a way of just smoothly moving the camera through some kind of motion. And I approximated that using the tools I have, but it wasn't that great. And I don't know that much of it was stable enough to use. Oh, Kaneko says someone asked what microscope I use, and they'd like to know as well. That's a good question. It's actually a really generic kind of thing. It's, it looks like this. And this thing is actually just the microscope itself. This is the stand it came with, but turned upside down. And this is like a generic lighting slash like photography kind of mount. Let me see if I can find this camera online really quick. You can get them in a lot of different places. When I got it, the going rate was around $130. Looks like they're a little cheaper now, like about 100. It looks like one of these. Don't worry about the brand name. Like they're just like generic devices that a lot of different people are reselling. I don't know what the original manufacturer is, but it'll look exactly like this. So just if you search for 1080p HDMI microscope and then look for one that looks like this, it'll probably be the same model. And it's like $100. It's low latency. You can use it for soldering. The picture quality is okay. The biggest gripe I have with it is it's interlaced. So if you're grabbing the video stream, you'll need to deinterlace it at some point, or you'll need to hack the camera's firmware to get it to put out progressive scan video. But that's basically what I use. Alright, so we've got all the transistors soldered. Next step, LEDs, and deciding what color goes where again, that kind of thing. I'm just putting a long leg in the square hole, oops, and trying to give it a checkerboard pattern, which I just failed at. Let's fix that. Oh, Jason suggests a binocular microscope. Yeah, so actually, way before I got this microscope, I got an optical microscope, and I haven't been using that as much lately since I've been mostly doing work for video, but I got that one when I was doing the reverse engineering work on the Nintendo DSi a while ago, and it seemed like time to invest in a microscope then, and it's been super useful, but I can't share it as much because I don't have a camera for it. And it's on the other side of the room. I could show you, but I don't have a camera, so I could mostly just show you through the eyepiece, which doesn't look very good. And I got my optical microscope from Amscope on eBay a while ago. I think at the time it was like $300. I was going to do this shot without the microscope, but I think no. Let's do this with the microscope. Such a good cat. Yeah, I really like my Amscope. It's one of the microscopes with a weighted base and then a boom that comes out and holds the head. And it's binocular. I'm trying to remember the magnification range. I think it goes from like 5x or so up to something like 70x. So it's like pretty low magnification, but it's what you want for electronics mostly. funny, thinking about the speculative execution side channels, I was thinking about just how much power there is in being able to measure time accurately. And wondering, like, you know, kind of going down the thought experiment path of thinking, well, how would you actually restrict access to accurate time measurement? Because it's not quite as simple as just like disallowing calls to functions that measure time. That would be the like first thing to do, of course, but there are a lot of other ways to measure time on a system. You know, like if you have another thread that you can communicate with, you can just have it run a busy loop and measure its progress. If you have any kind of I/O or multimedia, you can usually extract some kind of timing reference from that. But you need pretty accurate timing in order to usably exploit a cache side channel. Oops, just scratch the solder mask a little bit. So that reduces the number of timing sources you have. There's like shared memory and another thread, which I think the browsers at least are mitigating by removing access to shared memory arrays for now. And then Firefox at least had a mitigation where they add some random jitter to the clock, which seems like a good idea. But what about like web audio? I mean, how are you going to do audio without giving JavaScript an accurate notion of what time it is? Does this mean that audio is now basically an equivalent security risk to being able to probe other processes' memories? Yeah, so I don't know, that'll be interesting. So I think just for completeness, maybe I want this other board to use the opposite checkerboard pattern, so that there's one pattern on one side and the opposite pattern on the other side. Although if I put both boards together the same way, then I think it'll end up looking better because one of them will end up swapped. And then I'll, for example, have yellow and then green instead of yellow and yellow. So I think maybe I put both boards together the same way, and then I just end up getting that swap because of the rotation as I assemble it. So in that case, yellow goes here. Green. Ha! Ryan says now I need to see if anyone's connected a binocular microscope to an HTC Vive. That sounds super uncomfortable. Like, I don't know, I have a Vive and I like games that use that for immersion. Like, I'm really into, I don't know, like my favorite game is probably like Space Pirate Trainer, just because that is all about like being in a place and then just it uses like peripheral vision and motion a lot, but anything where you're like really concentrating on something kind of small, I think would be really not the right use for current headset tech, at least. But maybe once we have like way higher resolution headsets. Those are good. Let's get those flat and solder them in. Oh, the time lag would lead to burned fingers. Maybe that too, I don't know. I feel like you could do it, it would just be really uncomfortable. Like it would lead to a lot of just general fatigue and eye strain and... But I don't know, maybe it would be worth doing. Like, I do like the idea of using VR as a way of interacting with things that are like way too big or way too small to directly interact with. Yeah, I guess once you start having like virtual tools you could use to interact with micro positioners and stuff like that, that could be super fun. See, now I just want a game that's like that. Like a VR game where you're like wandering around inside of a chip and reverse engineering it or something. Yeah, the problem, I guess I would probably start down the path to making an engine for that and then just get distracted by making it like a real thing, because I have less patience for games than I do for tools. Oh, Waldos that work like that. Yeah, that would be fun. Alright, so we have LEDs and resistors. Both the boards look the same, except for varying amounts of cat hair on each. Let's see, what else is left? We haven't really figured out exactly where to put like the wires and headers yet. We know about the resistors, but the wires, headers, and capacitors we just haven't really looked at yet. Jason says, I think Tron was about walking around inside a computer. Yeah, maybe like Tron, but instead of written by like basic programmers, written by like particle physicists. That would be cool. Aw. Fly Mario says that I've got a crouton on my couch. Yep, I agree. What a beautiful little croissant. Okay. It looks like there are two places I could put the capacitor. All right, so looking at this again. Oh, that's a nice grid. 16? Do we have 16 resistors? Yeah. Because we have 8 LEDs and they each need 2 resistors. So that grid of 4x4, all of those are resistors. Then over here, I assume one of these rows is an opportunity to plug in an edge connector, and the other row is for linking the two boards together. So each one of these, like these 4 LEDs are connected back to these first 4 pins here, and then these 4 are empty. So I think the way to do this is, like for example, if I wanted the connector to be on this side, I'd put the connector on this side, and then use wires to link these other 4 back to this board. I could also swap that and put the connector on this side, and then use wires to link the top 4. So either way. And then for the power, I think it's the same idea where the connector goes on one side and wires go on the other side. And maybe just for fun, like I could do it opposite, so like power goes on one side and then data goes on the other side. That might be fun. It might be more useful for them to both be on the same side, I don't know. And then the capacitor, I think, could go in either this side or that side. I think they're symmetric. So we have one place where you can bridge from plus to minus. We can also go from plus to minus, or from plus to minus that way. That makes sense. I think we're about ready to do the cordwood part then. Let's put the headers on and then do the cordwood. So we have just enough header. It didn't give us any spare, so we've got to break off just the last two. Jason says the capacitors go on the outside by the arrow. Yeah, I get that part. There's just two places to put the capacitor. Because the boards are symmetric, like, you could put two capacitors on if you wanted to, but there just aren't two in the kit. I guess I should have done the headers before the LEDs, but this is fine. It would be a little easier to assemble if I put the headers on the inside and then the wires on the outside, but I think it'll be easier to use if I put the headers on the outside. So I think I'm going to do it that way. Like that. No, Jason's suggesting to do the headers last. I think it'll be easier to do the headers before I assemble the cordwood, so I'm going to do it that way. Alright. Got headers. There's power. There's that. Cool. Oh man, these look so nice through the microscope. Wire wrap headers, that would be cheating. All right, so maybe we mount the standoff to one board. At least like get that started. Surface mount resistor cordwood, that would be fun. Alright. Now this can go, let's just put it on that side maybe. Why not? Now, these are the 220 ohm resistors. Okay, I'm looking at the pattern on the stars on these resistors here. So this whole row is pull-up resistors with the stars. This whole row is pull-up resistors. Then the other two rows are the series resistors, which are the 220 ohm. So 220. People keep telling me to use scissors to remove the resistors from the tape, and this time I'm pulling them out. The scissors are right there. I have 2 pairs of scissors on my desk, but this time, for some reason, I just don't want to sacrifice that length. I'm trying to keep them as straight as I can. I'm going to put all those resistors going in that way, and then all these going in the other direction. Oh, nice. Austin says, hello from Stockholm. I checked the start of the stream. Looking forward to your slimy music video. Thanks. I've still got a little bit more to clean up after filming all of that slime. Man, we got some serious anti-flathead screw sentiments coming from YouTube chat. I agree that they're generally bad in a lot of ways, but they have a nice simplicity to them, which I can appreciate. Like, the cool thing about a flathead screw is just how easy it is to make. Not that they work well or anything, but you can turn anything into a flathead screw if you have a cutting tool of some sort. Alright, I think just picking orientations somewhat aesthetically here, but mostly arbitrary. Oh no. I mostly kept those in. Okay. I still need to cut some little pieces of wire to go in here too. It's hard to imagine why this assembly method isn't so popular anymore, or on circuits that weren't extremely space constrained. It's just so convenient. Okay. And as for wires, I need 6 of these. I guess it would have been useful to use the standoff to measure the length. Robertson is the one true head. I think I've got a Robertson driver somewhere. I'm gonna kind of eyeball the length here. You know, actually, I think it's easier to do the wires after, because with the wire, unlike the components, you can just feed them in one side and then get it just the right length, solder one side, cut the other. So I think I'm going to do that way. Let's save the wire for later and try to get the rest of these components in the holes. Let's get a better view on this. When I said better view, I didn't mean extremely blurry. Oh yeah, Ryan says you can buy boxes of Robertson in big box stores and they include a bit. That's probably where I got mine. Okay, so that's the bottom layer in, and now the camera's in my way. Try to duck under the camera. This is kind of like playing foosball. I keep having to move other resistors that are in the way of the resistor I'm trying to put in. Let's use some tweezers. I think I could use this piece of tape to help make it more stable, but I don't know if that actually would help. Well, I should double check all of that, but I think that's right. Let's maybe put the other screw in first thing. This is where a magnetic flat head screwdriver might help. Okay, so I've got that like just barely tightened, and then I'm also pressing both boards against my desk to get them lined up again. Oh, Ryan asks if I'm seeing my camera blink for a few frames every few minutes. I honestly have not noticed, but like it might just be this HDMI cable or something. Torques all the way, says Dimla29. A little bit too close to focus. Okay, so this is going from plus to minus. And I think the thing to do now is just to start centering these and soldering them into place. And the ones further back we're gonna have to center by pulling on the leads once we have a little more space. That could have been smoother. Maybe there's some way to stand these all up so that the legs all line themselves up, but I don't know. I don't really think that would work super well. Maybe I could actually tack a couple of these corner resistors and then just like stand the rest of them up to get them level. Let's try that. Oh gosh, yes. Ostin says, let's not die in the war trenches of screw standards. Yeah, there's a lot more worthwhile stuff to fight for these days. I think this is an extension of that most trivial hill I'm willing to die on meme that's been going around Twitter. Which feels very 2018 or something. Yeah, that seems better. If I can stand it up. Yeah, those seem plenty centered enough. Let's solder as many of those as I can. Rotate this. Good news, it's only getting more stable as I solder more of these. I think we're just down to the middle four. Okay, those are all soldered on that side. Let's turn it upside down. Tuco still asleep? Oh yeah, he's just a little out of frame maybe. See if I can point it. There we go. I think he was still in frame as far as the tracking algorithm was concerned, but the way I have the video cropped right now, it was actually hard to see him. Got all sorts of creaky noises coming from the heater. I keep getting an awful shadow right in there. Some of these individual solder joints are getting edited out because they're in shadow, but whatever. I think this is pretty much done. Just need to trim these, add the wires, and then test it. The lion sleeps tonight. Yes. Man, I remember hearing that song on the radio a lot. I think that joint needs a little bit of a touch-up. More flying leads right now than I'd like. Let's hold these. That's a good picture. It's paw prints in snow. There's our thing. It's getting really close. Got a lot of little resistor lugs, but they're a little too short to use as jumpers between boards. Kaiwana in YouTube chat says, I was all, wait, YouTube does smell-o-vision now? And then it turns out their flatmate was also soldering. That's great. has to be straighter. That's straight enough. And then I'm just going to have it barely poking through. So the idea is solder it on one side and then solder it and trim it on the other side. Twist in a drill? Kaneko says, the only way to get a wire nice and crisp is to twist it in a drill. Do you mean for straightening it? I had never heard of that approach, and it sounds like it would really fatigue the wire, but I'm curious to know more. Let's see, I think I want to cut this and then solder it. Interesting. I guess twisting it just takes all the existing kinks and just kind of randomizes them a bunch. I mean, the way I've seen rods straightened usually is with a machine that has rollers that kind of wiggle them around in one axis and then the other axis and just kind of massages out the non-straightness. Okay, similarly, another wire just barely poking out. I think so much of the puzzle in this puzzle is just figuring out what angle to hold all of your tools at. Okay, so we've got a capacitor across the power rails. We've got two wires conducting the power between boards. So I think all that's left now is wires in these bottom 4 holes between boards. Stop moving, camera. I've got to really awkwardly duck under the camera to do this. Actually, it might be easier to cut these and then solder them in bulk instead of trying to do this one side at a time now. Well, yeah, I don't know. I'm having second thoughts about this approach. Kind of works. Let's just try soldering both of these. It'd be easier to solder these all from the inside, like that edge. Although it's also behind the headers on that side. Anyway, almost done. Just 2 more of these. I'm just gonna cut the rest of this in half. Oh, actually, I started on the wrong one. Whoops. I need to move the top one down. trying to see if I can conduct enough heat through the wire to just heat it up at one end and get both sides to melt. I might not quite be able to do that. Let's go ahead and solder these bottom two in place. Alright, wire extracted from where it wasn't supposed to be. Cleaned up slightly. All right, that's better. I really can't see what I'm doing from that angle, and it shows. Let me just put some flux on there to clean it up. Well, maybe trimming this first. Jason says I have to solder in all the empty holes now. Well, I was actually thinking about solder wicking the one that I filled in, but I guess that would work too. already. Maybe I will fill in all the extra holes and then clean the flux off. It's about time to test it, though. Awfully frustrating trying to make anything in such a tight spot look good. But this needs a little bit of cleanup, but I think it's about time to test it. So let's get like, what was the logic voltage for this? 5 volts or 3.3? It seems like it should work on either. Just checking the instructions to see if they, I thought they said something about logic voltage. I mean, it seems like it should work on like up to, I don't know, like 15 volts or something. Oh, here we go. When connecting to a board, make sure that the IOs can tolerate the voltage levels that are applied to the cordwood. Oh, gotcha. Yeah, because of the pull-up resistors. That was what it was saying that I was trying to remember. All right, let's just grab some 5 volts. Jason says it's definitely mains voltage. Yeah, right. Yeah, the LEDs would get a little warm, and the transistors would almost certainly fail. Alright, I've got 5 volts at like half an amp here, which should be plenty. Alright, 5 volts. Contact. Nothing? What did I do wrong here? Let's see if I'm actually getting power. Yeah, I've got 5 volts. Let's look it back up to power and look at voltages. I was getting no current draw, which could mean that the LEDs are in backwards, although I was pretty sure we checked that. I'm not getting 5 volts across the capacitor. Oh, the capacitor's in the wrong spot, but that wouldn't be causing this to fail to light up. Or, is that true? Oh, yeah. No, I think the power is hooked up wrong. Yeah, because these are not actually connecting plus to plus. It's actually swapping power to the second board. Which would explain why neither board's lighting up, because one board is reverse biased and the other board is getting pull downs instead of pull ups. So that's our problem. So these just shouldn't be straight through. That's the problem. These are allowed to be straight through because the order doesn't really matter. But this is wrong. Yeah, we could just have 2 crossed wires, like from this plus to that plus, and from this minus to that minus, and that would work. There wouldn't be an obvious place for the capacitor to go, but the capacitor could go in either of these 2 places. That's just kind of in the way, though. I don't know if there's actually physically space for that. And either way, I think I'm going to have to take out all of these, and I don't know if I'm going to have enough length to reuse these pieces of wire, so I might need to get different pieces of wire. I did get the wire out just by going back and forth between the ends. I would use 2 soldering irons, but then I would also need a hand to apply pressure with, which I don't have. And I could bend the leads and just take one out at a time. I'm just trying to avoid that. But maybe I need to do that. Alright. And I think I'm going to sacrifice both of those wires. So let's just cut them in the middle. think I made a very similar mistake on the first Cordwood puzzle too. Alright, those are all out. So I think this wire is comparable. Yeah, this is, I think, 20 gauge. So I was thinking this wire, sorry, stop wiggling everything. So this wire, I think, would go from like this plus up to that plus, so it's crossing only in like this plane. I just don't think that leaves any room for the capacitor anymore. So the other possibility is the capacitor stays on one side. Like, I could have actually left the capacitor where it was. But then, no, I can't actually do the swap in the middle here because those would actually touch each other unless I had the wires not actually be straight. And I think I want to assume that these wires stay straight. So they can cross in that plane. Yeah, I mean, at this point, I get how to hook up the power. The problem I'm trying to solve is just like physically how to fit the two wires and the capacitor on there without them touching each other. I could put heat shrink on. I think that's cheating though. I want to see if there's a mechanic, like just a layout way of solving this problem first. It does look like the simpler, elegant solution that this is probably aiming toward is to have the two wires cross between those outside connections and then to have them bend around the capacitor somehow. So yeah, this probably does mean the wires are not straight but bent. Let's try that. Let's also clear out some of these holes because I will need the holes. I had some desoldering braid right over here somewhere. I have the tiniest desoldering braid. Okay. It doesn't quite work, and I really can't get my face into the right position here. flux in this braid has a pretty distinctive smell to it. I don't think that's quite enough to get these fully clear. Oh, Ananexus says the capacitor itself should keep the wires separate. I guess that's true. I hadn't thought about relying on that, but you're totally right. Yeah, I think we got the mystery solved. I just need to get these holes clear. I know I don't need to get all the holes clear, but I would like to get at least the holes we're using clear. Oh man, it's tempting to use my my air pump solder sucker, but I don't know if that'll quite have enough room in here. It's a pretty tight spot. I just cannot get my face in there. The wrong tool to be using for this job. I'm gonna look for some thicker braid. This stuff is not much bigger, and it's not pre-fluxed, but maybe it'll work. Wow, this braid is like starting to turn green. That worked. That one, there we go. Good, all those are clear, and let's clear at least a couple of them on this side. I am making a bigger flux mess, but I'm gonna clean this off once we test it and it works. Oh, Tuco's camera. Let me scroll this up a bit. The drift compensation's a little off and it just wants to go back down. That's fine. This is easier with a small piece of braid and not the entire spool. Yeah, that's much nicer. It's so sad when people try to use braid without any flux, it's like an easy mistake to make if you're used to seeing people use braid that's pre-fluxed, and then you get some that isn't pre-fluxed, and it just doesn't work. Because it's just night and day. It doesn't work at all without flux. I've seen a lot of people just like get really frustrated and assume they don't know how to solder when they're just using the wrong tool. A little bit more on there. Okay, those are clear. Let's try this again. Straighten the capacitor as much as I can. Put the capacitor in first. It's gonna have just barely enough leg length. And it can go in either of those two straight through holes, because if it's straight through, then it's actually connecting to the opposite net because the boards are mirrored. So that is minus on this side, plus on this side. All right, straighten that slightly, and then there's two more wires. Jason suggests to bend it in a form so that it looks cool with sharp angles. I don't know if I want a sharp angle there, but I do think bending the wire would be nice. I'm going to give it a bit of a curve before putting it in, and then try to get the curves looking nice once it's in place. So I'm just bending both of the wires just slightly with my thumb. So they look kind of like that, just to get the curve started, and then actually, pretty much none of the curve can happen before pushing the wire into place, because like getting the wire into both of those holes requires a good bit of manipulation. And that one actually doesn't look like it's going to touch the capacitor at all anyway. Let's see what we can do with the other one. Yeah. Let's see how much we can nudge the capacitor up. That's a little tight, but I think it's gonna work. Let's use pliers instead of tweezers, because I'm gonna break my tweezers trying to use them like pliers. That looks okay. Capacitor's got some room. Wire's got some room. The angles don't look terrible. Okay, that's better. That's crossed over. And then the capacitor occupies either one of those two straight through, which are actually crossed over. All right, let's test this and then clean it. Minus on the right, plus on the left. And we should see all the lights turn on as soon as I attach this, if it's working. Ooh. Got those. And these. It looks good so far. A little bit of a fade from the capacitor. My clip appears to be slightly broken, and so it wasn't actually holding on consistently. You can see this one's seen better days. It's held some hot things. All right, power. Let's try, what do I have that'll generate a good test signal for this? Something that counts and gives me a high impedance output, maybe. I could just like program an Arduino or something, but I think right now the level of complexity I'm looking for is a resistor attached to an alligator clip. So I'm gonna grab like a 1K resistor to use for this. I just threw off the camera. Why do you want to go that way, little camera? Actually, I can show you the debug output. Where was it? Yeah. Wow, it detects the sofa as a sofa. That's pretty cool. And the snozzberries taste like snozzberries. Alright, so this 1K resistor should be able to overwhelm the 10K pull-up in there. So I'm gonna ground the this 1K resistor and try to use this to turn off individual LEDs and see if they'll work. So here's our IOs. Cool. So that's this side. How about this side? Or this one. Depth perception fail. Did I? Oh no, did I put all of these wires in the wrong place too? Oh, I totally did. Man, I got really sloppy with the wires this time. Okay, so these 4 pins are for the bottom LEDs, which means these are not useful. I could move the header, but I think it's easier to move the wires. If I touch these up here, those work. Okay. All right, one more problem. Let's move the wires. I just did all of this wrong. Put the additional 4 through. I guess I could do that, but I don't know. I'm gonna try moving these. This is really annoying. This is possibly the most annoying way to take these out. Oh man, this kit is just like, it's like a trap for dyslexic people. Oh, let's get a new card. Yeah, the card might be full. Oh, Big Tuna in YouTube chat is asking what the circuit does. It's basically a bunch of on-off switches to control these LEDs. So it's, in the simplest form, you hook it up to power and it just lights up, but then you can also hook the inputs up to some other circuit, and it acts like a simple amplifier that converts logic levels into enough power to turn the LEDs on and off. But it's mostly a puzzle. Man, now what am I gonna do with this video? Is it gonna be like all about rework? Or what? Because there's always a, you know, because of course every video I make involves making tons of mistakes. And it's nice to leave some of those in, but sometimes like leaving too many in is just distracting. So it's kind of a decision about what I want to make the video about sometimes. Alright, bottom 4 wires extracted. So let's clean out the holes. I'm just remelting the solder on the bottom 4 to make them a little more uniform. But let's see, on the top, these holes are already mostly clear, but I need to clear one of them out and then clear all 4 on the other side. Jason suggests speeding past it with a quick voiceover explanation, which is certainly a possibility. that's the really tiny braid. I think I meant to get more of this stuff, not more of the really tiny braid. That seems better. You know, with all the weird interior surfaces, maybe this would be a good project to clean ultrasonically. Ultrasonic cleaning is not something I've done on stream because it mostly involves a lot of waiting and really terrible noises. But we could try that. I might also just take a brush to it. Oh yeah, good idea from Whisperfist, speeding up doing it wrong and then doing the fix at normal speed. Yeah, I kind of like that too. Alright, so I think we are ready on the whole end. These little pieces of wire, I could clean up the little pieces of wire and reuse them, but I think I might just use new wire since I have some really similar wire right over here. Since I don't feel like cleaning solder off of wire right now, I'm just going to get some new 20 gauge uninsulated over here. Oh, good question. Big Tuna is asking a follow-up question about the circuit and what it does and what does it mean to convert the logic levels. I guess maybe even more accurately, I guess I mean kind of converting impedance, but I know that probably doesn't help right away. So what these transistors do is these act like controllable on-off switches for each of the LEDs. And so this is a pretty classic use of a transistor. Like transistors can do a few different things, and you can hear them described as like different kinds of amplifiers or switches. But this is a pretty classic way of using a transistor to turn on and off some potentially larger load using a potentially smaller control signal. So that's kind of what these are doing. And the LEDs are still not large as far as like electrical loads go. They don't take a lot of power, but you can control the LEDs with this circuit using this like very, very small signal, which the transistors will then kind of pick up and amplify. So, you know, it's like a bit of a redundant thing sometimes because these LEDs are low power enough that you can drive them directly from a lot of kinds of circuits. But you know, it's like partly the way it is, I think, because it's an interesting kind of like teaching circuit. It's simple, but it's something that's like that you can test easily and it has a very definitive result. But you can also use it as a building block for other circuits that maybe couldn't drive the LED directly. Like some kinds of logic chips would have trouble driving the LED directly, or if you wanted to connect this to some other circuit that's already driving something else and connecting the LED to it would sort of change the voltage levels enough that it might change its operation, then you could connect this kind of circuit to those logic signals and see the status of the logic signals without affecting them much. It's a pretty good demonstration of one way to use this particular kind of transistor, the N-channel field effect transistor. All right, I'm just gonna make sure I'm doing this right. So this one and the 3 right below it. Just cut 3 more that are about the right length and then put them all in and solder them all and trim them. Yeah, and another way to think about these transistors, so they're field effect transistors, and sorry, I'm just trying to look. Yeah, so as Jason was saying, they're acting as a sort of a voltage to current converter, which that's one way to think of them. It's like BJTs you can think of pretty accurately as a current to current converter, so it's like a current amplifier. Field effect transistors are kind of like a voltage to resistance amplifier. So the higher voltage, the lower the resistance, basically. But it's not linear, and usually people think of it as having a threshold where it's kind of on or off, because it does tend to switch relatively fast. But you can also use them like an amplifier and kind of have them be partially on. But then these 10K pull-up resistors kind of, like, you can think of that as being a separate thing. You can also kind of think of that as modifying the way these transistors are being used into kind of a current amplifier, because the transistors will, or the resistors, sorry, will end up converting a current that's being sunk from that pin. It'll kind of convert that into a voltage. One side. Oh, position them so I don't need to trim them. I guess. I don't know. I don't think it's worth fussing too much about that. I mean, I'm gonna have to solder them in this awkward position anyway. They tend to move around while I solder them because of surface tension. So it's faster if I can give them enough room on both sides where I don't have to worry about them moving. That'll do. Okay, it's pretty messy, but maybe this is right. Let's try that again. All right, got them all lighting. Got our little test resistor. So just to continue the explanation of the circuit a little bit, the reason I'm using this 1K resistor is sort of to prove the amplifier is working. Because if I was, it's sort of like The most interesting use of this would be if the input signal was high enough resistance that that by itself couldn't turn on the LEDs, or at least not to the same brightness. And it's a little harder to demo with LEDs these days because LEDs can light with very little current because they're just so efficient now. But especially with turning off LEDs with a 1K resistor, this will kind of show that you only need to sink a little bit of current to kind of overwhelm that 10K pull-up and then sink the voltage down below the threshold where that transistor turns on. So by attaching this to one of the inputs, we make a voltage divider where this 1K resistor and the other 10K resistor pulling up are kind of fighting against each other. And we end up getting 1 divided by 11 as the ratio there. So 1K divided by 1K plus 10K. So 1/11th of the original voltage is what ends up showing up at that gate of each transistor, which is too low to turn on the transistor. And that turns off the LED. So, got left 4, and then can we see the right 4? Yay, that's correct. A nice suggestion for NNXs to have some snips that have an angle right at the end. That does seem nice. It'd be nice if I had a mirror underneath that actually would show all the LEDs. Maybe let's use Dory's bear postcard down here. You can kind of see all the LEDs. It'd be better if I had less ambient light. Now it just needs to stop shaking. Well, that's fun. I think it just needs cleaning now. Oh man, this camera's wobbly. Great. Wow, well thank you, Sar. This is another delightful little puzzle. Fun to build, fun to look at. It's just a little messy. Maybe I will ultrasonic this one. I don't know. I bet 30 seconds with a brush would take care of it too. trick is I just need to find the brush. Sorry. All right. Skim wipe. Nice. I like the way Internexus thinks. They want to build one of these with magnet wire instead of headers, and then encase the whole thing in clear resin. Yeah, it's a nice kit. I think if you did have the urge to build one of these, I think you can just buy a lot of the extra stock of previous kits directly. I should check that out, actually. Let's see if we can find that page. Products. Yeah, maybe this one isn't still available. I thought there was a shop where you could get individual kits. Let me see if I can find that really quick. Oh yeah, there are some things you can buy, but they're all sold out. So that's why the shop link was hard to find. So yeah, sorry, I guess the only way to get this is to sign up for the Boldport Club and get the future kits. Might be able to find one online somewhere if somebody's selling theirs, but I guess that's it. Limited edition. Oh, Jason's asking what the cleaning solution is. This is 99% isopropanol. You can use 70%, it's okay. I just don't like to leave water residue on electronics. So the higher percentage stuff is better for electronics cleaning. Oh yeah, it isn't ethanol here, it's isopropanol. You could use ethanol. We like to save that for drinking around here. Yeah, actually, it's funny. I've seen people like have like high percentage ethanol for cleaning. I mean, if I'm sure it's denatured, so you can't drink it, but I just haven't found that super necessary. I just got a big jug of isopropanol, and various concentrations of that tend to take care of most messes I've got around here. And for electronics, you can mix it with distilled water. You don't want any kind of like mineral residue or anything like that, but like I think if you got 70% isopropanol, it wouldn't have like minerals and stuff in it, so that would be fine too. It would just take longer to evaporate afterwards. And of course you wouldn't want to use it on stuff that's powered because you could have conductive ions in it. Jason asks if I use this in the ultrasonic cleaner. That's a good question. It's not a good idea to use the alcohol directly in the ultrasonic cleaner, because I think it's just a fire hazard unless the cleaner is designed for it. But what I will do is seal a plastic bag with a mixture of isopropanol and water and the electronics I'm trying to clean, and then put that sealed bag inside of another bath of distilled water in the ultrasonic, and that's what I use. So there's a little bit of solvent in the bag that doesn't get out, and then the actual overall water bath is just distilled water. So that's what you can use if you want the ultrasonic to just get all the alcohol-soluble stuff off easily, but you don't want to use much solvent and you want to keep it contained. I think this is mostly done. All right. I think that's pretty much done. Let's maybe do a little bit of just photography of the end result here, but yeah. Jason says, I do similar, but I'm wondering if the ultrasonics work better with a different liquid for cavitation cleaning. I would think that no matter what, you still wouldn't want the overall water bath to be anything other than just water. Because, I mean, like, water is pretty sonically conductive, and if, like, the actual cavitation bubbles that do the cleaning are going to be in the fluid in your sealed bag anyway. Oh, interesting. Anonexus says there's also cleaning solutions made specifically for ultrasonic cleaners. I think the instructions that came with my cleaner said to only use water, but like maybe those solutions are fine. I don't know anything about them. Still looks a little messy. There are just still some bits of flux residue that the brush is not super helping with because the brush has a lot of flux on it. Yeah, right. Jason says, I find the TO92s arranged in a spiral to be very appealing. I agree. That is pretty nice. I should probably just wait and do some more photography of this when it's dry. Because right now, it's nice, but the inconsistent shininess is bothering me. Well, that might be a good place to end this stream. Ha! Jason says, too bad you didn't polarize the resistors? What do you mean? I was actually placing the resistors specifically. I didn't place them all in the same direction, but I put the rows alternating. So the middle ones are pointing this way and the outer ones are pointing the other way. Which, I don't know, seemed like a way to do it. The whole board is still a little bit sticky, like it maybe would benefit from cleaning some more. Well, maybe I will ultrasonic it later if the stickiness doesn't subside when it dries. But I think that's something to do off stream. Well, thanks for stopping by, everybody. Just checking for any extra chat. It looks like we're all caught up. Is Tuco still hanging out in his spot? Such a good cat. That's what I was looking for. Well, thanks so much for joining. As I was explaining at the beginning of the stream, there's a lot of ongoing projects and a lot of stuff I've been doing that hasn't really felt completely streamable, but I'm going to try to keep the stuff coming. And as always, thanks for everyone who supports the channel on Patreon or just by stopping by and hanging out, and especially, you know, folks who tell their friends or send hardware in. It's all super great, and it's you know, it's nice to be able to start another year off, you know, making electronics videos and trying to share the stuff I'm doing with folks. And let me know what you think. I'm on Twitter, I'm on YouTube, I'm on Twitch, you know, and I'm on Patreon. And if you have input, I appreciate that. If you just want to say hi to my cat, that's cool too. But yeah, we'll keep the streams coming and keep the edited videos coming. And I'll see you all next time. Let's try to get one more glamour shot of these together. Just realizing I was fidgeting with them in this way that might actually lead to a photo if I put the camera on. Happy hacking, folks. It's been nice hanging out. See you next time.